Hi, welcome to 1.5, Solving Quadratic Equations. In this lesson, we're going to learn how to solve quadratic equations using these four strategies. Completing the square, something that we just learned how to do recently. Factoring, something we should already know how to do. Using quadratic formula, something we will review. And then using our graphing calculators or Desmos. Okay, so when asked to solve a quadratic equation, it means to find the x-intercepts, or the roots, or the zeros. Okay, these three things mean the same thing. However, they're just referring to different forms of the quadratic. So the x-intercepts are referring to the graph. The roots usually refer to the equation. And the zeros, those refer to the function. Okay, so we can take a quadratic and we can represent it as a function. And the zeros for that function are the same as the roots or the solutions to the quadratic equation, or they're the same thing as the x-intercepts of the graph. All right, so real quickly, before we go ahead, we'll just go over quadratic formula. You would have learned this back in grade 10. This formula, the way how we use it is we take our quadratic, okay, and it usually should be in the form of an equation where it equals 0. And then we can grab our A, B, and C and just plug them in respectively inside the equation. And then we get to calculate our solutions for x. This part right here, the b squared minus 4ac, that's underneath the radical sign. This is called the discriminant, okay? The discriminant. So we'll talk about the importance of this in a bit. So for now, let's just go ahead and do our first example. We're going to solve some quadratic equations using the four different strategies. So let's apply these four strategies to solve this equation right here. And then we'll talk about the strategies that we prefer, and we'll justify any of our reasons to that. Starting with completing the square. So there's not a lot of space here. So I would just like to encourage you to kind of write a little bit small. I'm going to write a little bit large just for the sake of the video, and then I'm going to compress it afterwards. So complete the square. To take that approach to solve this equation means we're going to end up putting this into vertex form and then solving for x. First, when I look at this equation, I could see that I can actually take out a 2 out of each term. Okay, each term is divisible by 2. Instead of factoring it, because this is in the form of an equation, I can actually just divide by 2. So we're going to divide each side by 2. Let's write that over here. So each side of the equation by 2. So this term, 2x squared, when I divide that by 2, I'm just left with x squared. Negative 12x. When I divide that by 2, I have negative 6x. And then negative 14 divided by 2, negative 7. Okay. Now the right side of the equation is 0, and notice when I take 0 and I divide it by 2, well, I'm still left with just 0. Okay. All right, so now we have a simplified equation, and we can go ahead and start to complete the square. So our first step is to add and subtract b over 2 squared. Okay, that way we can put it in the perfect square trinomial form. So this is our b value right here. Let's go ahead and do that. X squared minus 6x plus, and I'll change colors to show the substitution, negative 6 over 2 squared. And then when we add one, we then have to just subtract one. That way we don't change the value of the equation. And then we have minus 7 equals 0. Okay, in my next line, x squared minus 6x. Now, negative 6 over 2 is negative 3. When I square it, we get positive 9. So we have plus 9, minus 9, then minus 7 equals 0. Okay, and next we will have to take this, and then we need to factor the perfect square trinomial part. So that part right here is this piece right here. Okay, so in this line, we're going to have x minus 3 squared minus 9 minus 7 equals 0. So where did this come from? Well, that comes from factoring this expression right here. Okay, remember these are perfect squares. So all I have to do is take the square root to get the first term, square root 9 to get the second term, and then I seal the sign of the middle coefficient right here. Okay, another shortcut, this value right here is the same as what we have inside of here, the b over 2. Okay, negative 9 minus 7, so this last part right here, that's going to be negative 16. So we have x minus 3 squared minus 16 equals 0. Okay, now we've completed a square. It kind of looks like it's in a vertex form. Okay, however, the question's asking us to solve the equation. Okay, solving an equation just means, it means for us to find x. Okay, so see we're given this equation here. We want to know what x needs to be for this to be true, for this to equal 0. What should x be? Okay, if we just put 0 in for x, well, this equation doesn't work out to 0. It'd be negative 14. So there's certain values for x that make it 0, and that's what we're doing. We're finding those. So we started off, we completed the square. Now we're going to isolate for x. Okay, we couldn't isolate for x before because there's two x terms in this equation, and it's actually very tricky to get x by itself. So in order to do that, you have to put it in vertex form, and then you can go ahead and start to isolate for x. So first thing I like to do is get rid of this negative 16. So we can add 16 to both sides. Add one to this side, add one to this side. So when I add a 16, it's going to cancel out with this one. And I'm left with x minus 3 squared. That's going to equal 16. Okay, next I need to do is get rid of this squared part. Okay, to get rid of that, I can reverse it by square rooting. So we will square root that, and that square root cancels out with the square. Whatever you do to one side, you got to do to the other. So now we have x minus 3 equal to the square root of 16 is plus or minus 4. Okay, and whenever we square root a number, we have two possible scenarios, positive 4 or negative 4. Okay, this is going to help me figure out the two equations. So my first case, we have x minus 3 equal to positive 4. And now I can go ahead and solve for x. I'll add 3 to both sides to get rid of that, and then plus 3. We got x equal to 7. That's my first solution. My second one is going to be when we use the negative part. So we have x minus 3 equal to negative 4. So we can add 3 to both sides to get rid of that one. Then we get x equal to negative 1. So these are my two solutions. Okay, those are my two solutions to this equation. Okay, what that means is we could actually take these numbers and we could plug both of them in for x, and we would get 0. That's what that means. Okay. All right, so that is the completing the square approach. Okay, I'm just going to put a box around my two solutions. Now I'm just going to need to compress this in order to fit the other solutions in here. Okay, completing the square is definitely a lengthy process, so these next three won't take as much time. Okay, we're going to look at factoring. Factoring is actually my preferred method, although they both do have their uses. So we'll write factoring up here. All right, so I'm going to start with our equation. First thing we want to do is we want to simplify this, right? Remember, we can divide out by 2 like we did last time. So divide each term by 2 and we get x squared minus 6x minus 7. Okay, let me just write that up here. Divide each side by 2. Okay, so divide this by 2, that by 2, and that by 2. And then once you're done doing the left side, you can do the right side. 0 divided by 2, also 0. Okay, so everything was divided by 2. We now have a nice simple trinomial. Okay, let's go ahead and factor. Factor the trinomial. Okay. All right, so I need two numbers that multiply to give me -7 and that add a -6. So I could do 1 times -7. Okay. However, when I add those, I'm going to get -6. Okay, that looks like that works. 1 times -7 is -7. 1 plus -7 is 6. So that worked. If I would have tried -1 times +7, then I would have got +6, right? And that wouldn't work. So those are my two factors. Let's go ahead and write this. X plus 1. So that's the first factor. This is the second one, the -7. X minus 7. Okay. And if you remember the zero product theorem, whenever you're multiplying factors together and they have to equal 0, well, that just means each one needs to be 0. Okay, so the first one, I'm going to set this equal to 0, then I'm going to find x. So I can just subtract 1 from both sides, and we know x is -1. That's my first solution. From this factor, x minus 7, set it equal to 0, solve for x, we get 7. Okay. So all we're doing is we're finding the value for x that makes the bracket 0. Notice the solutions. Okay, our factoring technique, these are our two solutions. They really line up exactly with what we got from the other approach. Okay. Now you can probably see why I said I prefer the factoring approach. It's definitely really efficient, and it's a great way of finding the solutions. The only thing, though, is our trinomial needs to be factorable, right? And not all of them will be. So when that happens, whenever you get an ugly trinomial, so not one nice like this, but something where maybe you have decimals or fractions, instead of trying to factor, which might not be possible, you can just go ahead and apply the quadratic formula. Okay, so I'm going to go ahead and copy this. Okay, this will be our quadratic formula approach. So to apply the quadratic formula, I got to identify A, B, and C in the polynomial. Okay, those are just the coefficients, right? And you have to include the negative signs too, right? So let's go ahead and substitute in. B is -12, so we're going to have minus and -12, plus or minus the square root. B is -12, so it's b squared minus 4. A is 2. C is -14. Divide all of that by 2 times A. A is 2. So we have 12 plus or minus the square root of -12 squared is 144. And then we have two negatives here. Okay, we have -4 times 2, which is 8. And then we have 8 times 14, which is 80 plus 32. So 112. All of that is over 4. So we have 12 plus or minus the square root of 256 all over 4. Okay, let's just make a little bit smaller here. All right. And the square root of 256. Okay, let's just do that real quickly. Square root of 256, 16. Okay, so we have 12 plus or minus 16 over 4. And we're going to finish this up here. So actually, let's write our solutions for x, right? Remember, this is x equals all of these lines. So I could finish this by saying x equal to, let's do the positive case first. 12 plus 16 over 4, which would be 28 over 4, which is 7. Okay, so that's our first solution. Then we can do our second case where it's negative 12 minus 16 over 4. We get negative 4 over 4, which is negative 1. So you can see we get the same solutions that we've been getting by using the other approaches as well. All right, so definitely if I were to compare this, quadratic formula definitely takes longer than factoring and probably the same amount of effort as completing a square. So the only time I resort to quadratic formula is if I look at my quadratic and I realize that I can't factor it. Okay, lastly, we'll check by graphing. So let me just enter this in, y equals 2x squared minus 12x minus 14. And there's our solutions at negative 1 and 7. Those are the x-intercepts. So that's another approach you can take to solve the quadratic. You can just graph it and then get the x-intercepts. Okay, so by graphing, we would have a x-intercept at negative 1, another one at 7. So my solutions would be negative 1 and 7. Okay, this is also an acceptable way to write out the solutions by listing them with a comma. Okay, you are able to do that. So just highlight this. And that is the 4 strategies for solving equations. So we can complete the square, not the most easiest process, but definitely still works. Okay, and you can actually complete the square for any quadratic. Okay, even if you have fractions, even if you have decimals, you can do it. Okay, factoring, best method by far. However, this has to be factorable. Okay, once you factor it, your solutions are right there. Just get the zeros. Okay, those are your 2 solutions. Quadratic formula. Okay, a little bit lengthier, maybe than the other 2, but always works no matter what, especially when you have an equation that is not factorable. Graphing, definitely the fastest, especially if you're using Desmos or your graphing calculator. If you are using your TI-84 or any other graphing calculator, I will put together a video showing you how to find the x-intercepts on your graphing calculator. Okay, being able to do that makes this work really easy too. You do have to be able to know how to do all the methods. So it's not like you can just kind of pick graphing and do that all the time. So when it comes time for a test, I will ask you to use certain methods. All right, so solving 2x squared minus 12x minus 14 equal to 0 is equivalent to finding the blank of the function. Okay, so when we write this as a function, it'd be like finding its zeros. Okay, so the zeros correspond to this in the function form. The roots correspond to this equation, the x-intercepts correspond to the graph. All right, in this next example, we will look at making connections between the number of zeros to a graph with its form.